Hello my friends and welcome to this new practical activity for decision tree classification. Wow, we're almost at the end of this part 3 classification, and the first thing I suggest is to recap on what we obtained so far with our previous classifiers. So with logistic regression we got an accuracy of 89%, with KNN we got the best accuracy of 93%, with SVM with a linear kernel, we got an accuracy of 90%. With kernel SVM with a nonlinear kernel, we got again an accuracy of 93%. And with naive Bayes, we got an accuracy of 90%. Therefore, the two best models we had so far are KNN and kernel SVM. And so now the big question is, can we still beat that with one of our two classification models that we have left, decision tree classification or random forest classification? And in this new section we're about to implement decision tree classification. So let's do this, but first let's make sure everyone here is on the same page. I gave you the link to this whole folder right before this tutorial in the article, so make sure to connect to it. And now please follow me into part 3 classification to implement this time the decision tree classification model. And as usual, we're going to start with Python. This Python folder contains two files, the implementation of the decision tree classification model in IPYNB format and the same dataset, social network ads.csv, which contains information of 400 customers of a car dealership which just released a brand new luxury SUV, and the strategic team gathered this data to understand which customers buy the most the SUV in order to target them with ads that will be posted on social networks. So each of these rows correspond to different customers, and for each of these customers we have two features, the age and the estimated salary, with which we're going to predict the dependent variable purchased, which takes binary values, 0 meaning that the customer didn't buy the SUV, and 1 meaning that the customer bought the SUV. Alright, let's do this. Let's see if decision tree classification can beat the previous accuracies we got so far, meaning 93%. So without further ado, let's open that with Google Colab, choose your favorite, and I'm gonna put it here because this is our next classification model. Alright, perfect. So once again, this implementation results from that classification template we made in the first section of this part 3 when we implemented the logistic regression model, and therefore the only cell that changes here in this implementation is, as usual, that cell where we build and train the classification model, right? This cell here. And all the rest, all the other cells are exactly the same as in the logistic regression code template, or the classification code template, because indeed we use the same variable names, classifier, and then xtrain, xtest, everything is the same except this cell. So once again, we're going to re-implement this cell, but to do this we need to create a copy, because this is in read-only mode. So right now we're going to create that copy on which we will be able to re-implement that cell. All right, so let's scroll down again to find that cell where we build and train the decision tree classification model. Now let's put it in the trash immediately, because I don't want you to see, the name of the class, because indeed I want you to find it on your own. So there you go. Now is the time you press pause on this video to find the right class name that allows us to build the decision tree classification model. You will have to either look for it directly through an online search, or the other option, and the one that I recommend to you because I want you to get familiar with the scikit-learn API, that other option is to look for it inside the scikit-learn API. And this is exactly what we're going to do together in 2 seconds after you press pause. And alright, let's do this. So let's go to the scikit-learn API to find the class that allows us to build a decision tree classification model. Alright, so API, and by memory, let's suppose actually that I have no idea of the module or even the class that builds this decision tree classification model. So here I'm scrolling down, to observe the different modules. Maybe it is an ensemble method, because I know that random forest, we built the random forest regressor in part 2. Random forest is an ensemble method, but no, here we don't see the decision tree. So let's scroll back down again, which makes sense, right? Because the decision tree is just a single model. It is not an ensemble of models. All right, so manifold learning metrics, no. You know, it's really important that you get familiar with this API, because the more you get familiar, the more expert you'll become and the better you'll juggle with all the machine learning tools, you know, besides the one that I'm giving you in this course. All right, so here I'm scrolling down more. All right, preprocessing, random projection, semi-supervised learning, support vector machines, decision trees. There we go. You know, usually the module you're looking for in the scikit-learn API will have the same name here as the model you want to build, right? And you know, this is organized in alphabetical order, so that's why I wanted you to do this exercise. It's actually very easy to find what you want. All right, so decision trees, and now which one do we want to get among these? Well, that's of course the first one. You know, that was the one we used in part 2 regression, but now we're doing classification, so we want the decision tree classifier class. All right, so now what do we have to do first? Well, let's do, you know, what we have to do anyway, which is to import that class. And so I'm copying this, and then back in my copy, we're going to create a new code cell. We're going to paste that, and once again, we're going to start from scikit-learn and then the tree module by scikit-learn. And from that tree module, we're going to import the decision tree classifier. So that's the first step, right? You know it by heart now. And now the second step, I don't even have to tell you. It is, of course, to create our classifier object, which will be created as an instance of this decision tree classifier class, and which will represent nothing else than the decision tree classifier model. All right, so here we add some parentheses, and now the second question is, what do we have to input here as parameters, you know, of this decision tree classifier class? So let's see, let's go back to the documentation, the scikit-learn API, and well, this time we actually have a lot of parameters. So if you want, you can read all of them, their description, in case, you know, you want to tune later on a decision tree classification for one of your future machine learning models. But in our case, and this is just in order to be aligned with what you learned in the intuition lecture by Kirill, you know, in order for you to be aligned with the theory, well, we will just change one, you know, default value of the parameters, which is this one, criterion. So the default value of criterion is Gini, but with respect to what you learned in the theory with Kirill's intuition lecture, we're going to choose an entropy criterion. Right? This is what you learned in the intuition lecture. So the criterion is, of course, the function to measure the quality of a split, and that quality is measured by entropy, at least what we're going to choose here. Okay? You know, remember entropy for the information gain. All right, so that's the only thing we want to input here. All the rest, we're going to keep the default values. Feel free to read them if you need to learn more, but that's the main parameter. That's mostly what we have to select here. And then remember that we will also add a random state parameter to make sure that we have the same results displayed in our notebook. All right, so let's do this. Criterion equals, in quotes, entropy. Perfect. And then the second one, random state parameter, that we set equal to 0. Great. And now, final step, you know exactly what to do. We take our classifier, and from this classifier, we call the fit method to train our decision tree classifier on the training set that is composed as is expected by the fit method of X train and Y train. Exactly the same as before. And now once again, we're done very efficiently with this implementation. So I can't wait to see the results. I don't think we will beat the accuracy record, but let's see, we never know. So let's click this folder button here, and then, you know, right now it is connecting to a runtime to enable file browsing so that, you know, we can access your files on your machine. And in a second, we should be able to get the upload button. There we go, as usual. So upload, and so that's the right data set. Let me show you the path again. That's the whole machinery A to Z folder. Please find it on your machine. And then we're going to go to part 3 classification, then decision tree classification, then Python, and then social network ads.csv. All right, let's press OK. And now here we go. We are ready to run all the cells by clicking this runtime button and then run all. All right, and now it is training decision tree classification model. Here we go. We have it now, you know, with all the default values of the parameters except criterion, which we set equal to entropy. Then what about that new result? Great, we got the right prediction. Remember that customer of age 30 and estimated salary $87,000 didn't buy in reality the SUV and was predicted not to buy it either. So perfect. Then when predicting the test set results, we indeed get a lot of good predictions, except some incorrect ones here, for example. And then, well, it looks actually pretty good. Maybe, we will beat the accuracy. That's another one. All right, another one. And okay, let's see. Okay, because, there's actually also, when you scroll up, some more prediction. But let's see. I'm very curious. Actually, maybe I spoke too fast. We're about to find out right now with the confusion matrix. Are you ready? The accuracy of the decision tree classification model is 91%. Wow. Okay, so it's actually in the podium, right after KNN and kernel SVM, which got the best accuracy of 93%. Wow, so that's really good. Actually, this is really a good sign for random forest, because random forest is basically a team of decision trees making the predictions. And you know how team spirit always improves the results, so we might have a chance to beat the record accuracy with random forest. So that's pretty exciting. And now when visualizing the training set results, which we already got, the execution was not too long. Let's see what it looks like. Wow, okay, so that's pretty different as before, and no wonder why it got pretty good accuracy. Because indeed it looks like it was able to catch, the little observation points that were really hard to catch by either a straight line, with linear classifiers, or a nice curve like with kernel SVM or naive Bayes. Here we actually splitted this whole grid into smaller subgrids, and that's because, we have all these splits in the decision tree classification algorithm. So no wonder why we get all these subgrids, and therefore we get separate prediction regions. It's really interesting. That catches very well the observation points. So it catches all the red customers here who didn't buy in reality the SUV. It catches also all these green customers who bought in reality the SUV. And it catches, these very hard to catch customers here by creating indeed these subgrids of the grid with the right prediction regions. So you see how it got that good accuracy? It really tried to catch everything, even for example, these green points that were cut among all these red points, okay, these red customers. Okay, but that's, be careful, the training set, on which the model was trained. Let's see what happens with the test set. And we already know that we will get good results because we already know that the accuracy on the test set is 90%, but still, let's see what we get with new observations on which the model wasn't trained. All right, so this is what we get, and actually here we see things more clearly. This is the prediction region, which funnily was a good fit for the training set, but here it is not catching anything, neither red customers or green customers. Here seem to be two incorrect predictions, because they fall in the green region. Then here, that's all good, that's all the customers of small age and small estimated salary, which therefore won't be likely to buy the SUV, as it is the case here. And then all these green points are correctly predicted. This one is incorrectly predicted. So indeed, we have our 10 incorrect predictions in all this. But there you go. If I didn't see the accuracy first, I would be afraid that we have some overfitting here. But no, it doesn't seem to be the case. Even with new observations of the test set, we get great predictions. But now what I really want to see, what I really want to find out is the final accuracy of our final classification model. Because if we got these great results with a single tree, let's see what we're going to get with a team of trees, which is exactly the principle of random forest. So really, I can't wait to see you in the final section of this course, random forest classification, because we might have a chance to beat that record accuracy of 93%. Let's find out about this in the next practical activity. And until then, enjoy machine learning.